Well, good afternoon, good morning. We are going to talk about what CATIE, this is a regional center in Central America, do about coffee research, applied research and teaching on coffee. CATIE is a regional center which combines science, graduate education, and innovation to improve human well-being through integrated management of agricultural and natural resources in the rural area of Latin America and the Caribbean. We have three major pillars, which are education, research, and technical assistance. This is basically applied research, and then technical cooperation. Now we go into our main subject. It's about coffee. Coffee is really a globally important commodity. There are 11 million hectares cultivated of coffee at the current time, 20 million farmers, 9.2 millions of tons of green coffee produced annually, and more than 125 million people depend on coffee for their livelihoods. CATIE and other centers focusing on cocoa and coffee have a research focus which is mainly concerned about increasing productivity or adapting coffee to climate change. This is what you find in most coffee research institutes. But in CATIE, we do a lot of work also in agroforestry, but other research organizations are taking more actions into agroforestry research with coffee. In CATIE, we combine both with the emphasis is in agroforestry. In what follows, we will talk a little bit more about the different elements of agronomy, agroforestry, and education that we do in coffee. Only it's going to be a very quick presentation on this without getting too much into details. No? In the agronomy, we work mostly on genetic resources conservation and breeding. Coffee pruning system, the modeling, mathematical modeling of coffee pruning system, plant protection measures, and then decision-making model for rehabilitation and renovation of coffee plantations. In the case of conservation of genetic resources, we have one of the most important seed bank for coffee or genetic bank for coffee, Arabica coffee, with some 2,000 genotypes, including about 900 wild genotypes from Sudan and Ethiopia that were introduced into the countries last century in the 1940s and 50s. And then we have a breeding program. This breeding program is focused heavily on the production of F1 hybrids. We have been through three different cycles of hybrids production. In the first cycle, we start with crossing traditional varieties like Atura and Catuai with the wild genotypes, and also with Catimors and Sarchimors, which are coffee leaf resistant varieties. No? In all these crosses, the wild genotypes from Ethiopia and Sudan were used as males in all the crossings. Because of the F1 hybrids don't have the stability of the traditional variety like Atura, which went through maybe F12, 12 cycles of breeding. Because of the large variability in F1 hybrids, you select the best individuals and then you propagate those individuals asexually, going through the biotechnology lab, combined with some horticultural practices to speed up the process of producing a plant ready for the field and also to reduce the cost of the plant. In this particular case, we take the parent plants, we produce mother plants in the laboratory and the biotechnology laboratory. We take those mother plants from the mother laboratory, get into the forestry seed bank where they do clipping to produce shoots and use this rooted stake to produce the new plants that go to the nursery for planting into the field. This process speeds, this methodology speeds the process from the cell in the biotechnology lab to the plant ready for go to the field, and also decreases the cost in about 75%. In terms of plant protection, we focus a lot on the coffee leaf rust, which is one of the major fungal problems in Latin America. We don't have the coffee berry disease that is a plague in Africa, but we also have the coffee berry borer and some other fungal diseases like Cercospora and other. But the main problem in terms of plant protection in Latin America and Central America in particular is this coffee rust. So we work on this particular issue, looking for measures, biotechnology measures, practical mechanical measures, and management measures, and so on. Pruning is also a very important practice. It determines a lot of the yield. So we have done a lot of work. We recently published a catalog of the different pruning systems used in Latin America, which we now are able to model mathematically. We found a way to take any pruning system, you describe it in textually as we normally do. You translate that textual description into a graph, like the ones here on the upper right-hand corner. And then we use this description on the graph to develop a mathematical equation for this particular system, and we can use this system of equations to predict what's going to happen in terms of yield and also into financial aspects. We also work in optimization models for decision making in the rehabilitation and renovation of coffee and cocoa plantation, that they share many similarities. It has to do with the implementation of a new approach that involves not only a focus on the yield age curve of the coffee, but also in the agroforestry nature of the coffee production system, which involves incomes and also expenditures related to the management of the tree plants, like the timber or the fruit trees, but also the intercropping that is normally associated with the establishment of the coffee plantation, and also the investment that you need to do to restore the fertility and the site quality of the site before you start a new cycle of cultivation of coffee or cocoa. So we have worked on the mathematical optimization of this process. So we have now better tools or rehabilitating a plantation, how often and what fraction you have to renovate or rehabilitate annually, and see what the outcomes are in terms of money and financial performance. Okay, this is a very quick overview on the agronomy. In the agroforestry, we have done a lot of work on shade canopy design, how to optimize the shade canopy design for different purposes, productivity, and also environmental services. And then we have looked at the trade-off between ecosystem services provision, ecosystem services like goods and products for sale or home consumption versus the productivity, the biodiversity conservation, water regulation, and so on, with a focus on finding alternatives that combine mitigation and adaptation to climate change. We'll take a closer look at these aspects. We look at different systems from open zone cultivation to different kind of agroforestry designs, like the ones you see on the screen, from zero shade to different shade system using legume species that are pruned regularly, or combination with timber or fruit trees that, in addition to shade, they also produce goods that can be included in the financial balance of the farming system. Uh, as part of this study in the agroforestry section, we have a wonderful relationship with CIRAD and other organizations. So we established this platform. We call it Mesoamerican Scientific Partnership Platform, system with perennial crops, namely coffee and cocoa. And as part of this initiative and this platform, we have also looked at long-term experiments like this one that you see on the screen. This is a Google shot. This is in our campus here in CATIE, but there's a replicate of this experiment in Nicaragua in a completely different agroclimate. This is a very large experiment testing more than 20 different agroforestry systems and no shade system using different shade tree species, legumes or non-legume, timber, non-timber species. The management can be conventional with agrochemicals or organic, and different levels of agrochemicals and different levels of organic input. So it's a very large experiment. This is 9 hectares in total, and it has been monitored for already 24 years as we speak. Information and a lot of work we do in the look at the shade canopy design, this is central to the agroforestry strategy. And you realize that there is no one recipe for all the shade canopies. Every shade canopy is unique, even within the same farm and even within the same plantation. The shading condition in one area of the plantation has to be different from the shading of the same plantation in another area. So because there are no recipes, you have to really find out a methodology that can be applied in every situation, and you go through this process of methodological process, and then make decision according to the particular conditions in this particular situation. The methodology is based on the definition of a shade canopy as a 3D volume, three-dimensional volume. And then we use some software that we have developed, in this particular the shade motion software, to assess the shade levels and the shade patterns, both spatially and temporally, that occur when you design the system with a particular combination and planting arrangement of the trees. And then we use also a conceptual box and arrow models with all the mathematics involved into the representation of those interactions to see what the outcome of this particular combination of species will be in terms of productivity and also in terms of financial aspects. We look at also the problem of climate change, modeling the climate to see how different areas will shift from one place to another because of climate change. But we also look at the impacts of the different agroforestry system in terms of carbon capture, in terms of balances between regulating and provision services. And we also take into consideration the very strong need to reduce deforestation and also to avoid the loss of tree cover because of the intensification that normally takes place. They remove the shade. So the question is how you can intensify your coffee production system. How can you intensify crop husbandry without really removing the trees in your system? Then we will look at coffee research, education in terms of education, and CATIE is a university, regional university, international university. We provide basically graduate education. We deliver master's and PhD degrees alone or in combination and alliance with other universities in Europe and the United States. We give a lot of training courses to extension agents and NGO specialists providing technical assistance to farmers, and also implement development projects in different regions. And in those development projects, the training of farmers using farmer field school strategies is also a very important aspect of the implementation of the project, and we also do a lot of farmer field school work. There is one of our graduations. We have a number of students from all Latin American countries, even some African countries come to work in our program. And we spend a lot of time in also teaching farmers, like these farmers in Bolivia. So it's a combination of you go from postdoc, PhD, and master's degree program to training program for specialization programs for extension agents down to farmer field schools programs. Thank you very much for your attention. This is my presentation. I think I stay well within the limit of the 15 minutes. Thank you very much. Carla, te tengo.